Hi viewers, today's important topic is longitudinal vibration in a bar free at both ends. So bar has a free ends means not fixed in between anything. So already we have discussed about when the both ends are free, when both ends are fixed. Fixed means like this. When both ends are fixed, then we have written boundary condition y0 here, y0 here. Beginning point is x is equal to 0, and from here to here length is l, then this end is x equals to l. At the both end y value is 0. So for fixed one, for free one, see what. So longitudinal vibrations in a bar free at both ends. So for free, both for free, so here for the bar free at both ends, following boundary conditions are applied. So that means do y by do x is equals to 0, where the end is free. There we have to substitute this value, means we have to apply this value. Okay, so here a bar not fixed to anything, so that means this end and this end are free. So that means both end are free, means at both places this value present. So at the first place, first point, it is a beginning one means x is equals to 0. It is the last one means x is equals to l. Now solution of longitudinal wave is y is equals to a into e power of I omega t minus kx plus b into e power of I omega t plus kx. It is first equation. So it is, let equation 1, it is a solution. Okay, now we have to, if we want to apply boundary conditions to this, then what we have to do, we have to differentiate equation 1 with respect to x. Okay, so differentiating equation 1, it becomes dou y by dou x, and e power a into e power of I omega t minus kx differentiation is only x coefficient comes down. X coefficient is minus k into I, so minus ki. Similarly this side plus k into I. So why? Because we know e power of, if it is I, kx is there, its differentiation with respect to x can be written as I k e power of I k x. Whatever coefficient we have to the x, those coefficient comes down. Okay, now apply the first BC, first boundary conditions. What is the first boundary condition? This is a first boundary condition, also written here once again. And now substitute in the place of dou y by dou x is 0 and at x is equals to 0. So that means here and here and here we have to substitute 0 values. Okay, substitute here also, and then this is a formula. Now take out the common factors. So common factor ik e power of I omega t common, then in the bracket minus a plus b. So we know this term never 0, then automatically this term is 0. Okay, so it is 0. Then we can write b is equals to a. Why? Because minus a plus b is equals to 0 means minus a is equals to minus b, minus cancel. A is equals to b can also be written as b is equals to a. Now substitute b is equals to a value in the equation 1. In the equation 1 only we have to substitute here. So that means in the place of b we have to substitute a here in the place of b. And now what we have to do, separate exponential terms. Yes, like this, separated. And after separation take out the common factors. These are the common factors. Yes, common factors taken outside. In the bracket e power of I omega I power of I minus I kx plus e power of I kx. But actually minus term has to present right side, and this one has to present left side. So rearrange them. So see here it is rearranged. And now divide with the 2 and multiply with the 2. 2 is divided and multiplied. Then this is the formula of what? Cos kx. So like this cos kx is written. Now let it is equation 3. A differentiating above equation with respect to x. Y, if we want to apply the second BC, again we have to differentiate it. Okay, differentiated cos kx, only x term, where we have the x term that will differentiable, remaining or constant. So here only we have x term, then cos becomes minus sin kx, and k outside, it comes outside, isn't it? K is outside. It is equation 4. Apply the BC for the equation 4 boundary condition, second boundary condition, that is dou y by dou x is equals to 0 at x is equals to L. So in the place of this 0, in the place of x is L, right? So we know this term number 0, then this is equal to 0. Now what values of KL sin value is 0 means, if we substitute KL is equals to 0, sin 0, KL is equals to pi, sin 0, KL is equals to pi, sin 0, so on k, all the k and pi values, it is 0. So KL is equals to n pi, n value starts from this. If you substitute 0 value, you get this one. If you substitute 1 value here, you can get this one, like this. But we know k value omega by c, so omega by c into L is equals to n pi. Keep omega and bring remaining two things that side, so it comes down, it come up, and omega can be written as 2 pi f. 2 pi f, here pi cancel, f is equals to n by 2L into c. Why? These two come this side, and c value we know that is c is equals to under y by rho, where c is the velocity of longitudinal wave in a bar. So it's a generalized formula is this one, and a substitute f is equals to, n is equals to 1, then f1 is equals to 1 by 2L under root y by rho. This is, so this is called fundamental frequency. N is equals to, substitute n is equals to 2, then f2 is equals to 2 by 2L root y by rho. So 2 by 2L root, this can be written as f2 is equals to 2 by 2L root 1 by y by rho, means it is also written as f2 is equals to 2 into 1 by 2L root y by rho. But this is what, it is a fundamental frequency formula, so that is f1. So f2 is equals to 2f1, so this is called first overtone. Okay friends,